All right, today we're going to talk about time travel. But forget the DeLorean. We're talking about a $10 billion observatory parked about 1,000,000 miles from Earth. We're going to dig into how the James Webb Space Telescope is giving us a literal front-row seat to the birth of the entire universe.
So let's just start with a kind of a wild thought experiment. Imagine you had a telescope so powerful you could see the Earth from 65 million light-years away. Now, because light actually takes time to travel that distance, the light leaving Earth during the age of the dinosaurs would only just be reaching you right now. You would literally be watching a T-Rex stomp around.
And that isn't science fiction, you know? That's the basic principle of astronomy. Every star you see in the night sky is actually a picture from the past. Light from our closest star neighbor takes over 4 years to get here, so we're always seeing it as it was. Now, what if we could take that idea and just push it to its absolute, most extreme limit? Well, that is exactly what the James Webb Space Telescope was built to do. Okay, so let's get into this absolutely incredible machine. This isn't just another telescope, it's honestly one of the most ambitious scientific instruments ever put together by humanity.
Yeah, this thing wasn't just a weekend project. The JWST took decades of development, costing a staggering $10 billion. So, what exactly does a $10 billion time machine get you?
Well, here's where you can really see the massive leap in technology. I mean, just look at it compared to the Hubble. Webb's mirror is a total giant. It's almost 3 times wider, but, and get this, it's actually lighter. This isn't just a bigger mirror. We're talking about a whole new class of instrument.
When you put it all together, this bigger, lighter, and way more advanced design gives the James Webb Telescope about 100 times the power of Hubble. That's the power to see farther, clearer, and deeper into the cosmic past than we've ever been able to before.
So how in the world does all that power let us see the very first stars? I mean, how is it possible to look back over 13.5 billion years to when the universe was just an infant? Well, the secret isn't in the light we can see, but in the light we can't.
Okay, picture the universe as a balloon that's constantly expanding. As light from the very first stars traveled across this balloon for billions and billions of years, space itself stretched that light out, kind of like pulling on a wave and making it longer and flatter. Astronomers have a name for this. It's called redshift.
So this stretching process actually shifts visible light way past the red end of the spectrum, turning it into infrared radiation. That's a type of light that's completely invisible to our eyes. And that's the key. The Webb telescope was designed from the ground up to be an infrared observatory, so it can see this ancient, stretched-out light that a telescope like Hubble just couldn't pick up.
Now, to catch these incredibly faint whispers from the dawn of time, the engineers had to invent brand new technologies. Seriously, the telescope they built pushes the boundaries of what anyone thought was even possible.
So let's start with that giant mirror. It's not one single piece of glass. A mirror that big would just be way too heavy and way too fragile to ever launch into space. So instead, it's made of 18 individual hexagonal segments that all have to work together perfectly as one.
Each of these hexagons is made from a really lightweight metal called beryllium, and it's coated in this super thin layer of gold, which is perfect for reflecting infrared light. The whole thing was folded up like a piece of high-tech origami just to fit inside a rocket, and then it had to unfold itself flawlessly out in space. And the alignment? We're talking about a precision of 1/10,000th the thickness of a human hair. I mean, it is an unbelievable feat of engineering. Okay, but that creates a huge problem. Infrared light is, well, it's basically heat. So the telescope itself, if it got even a little warm, would glow with its own infrared light and just blind its own instruments. It'd be like trying to take a picture of a tiny candle while you're standing inside a bonfire. So Webb has to be unbelievably cold. And the solution is another engineering marvel. A 5-layered sunshield the size of a tennis court. Each layer is made of this special film called Kapton, and each one is thinner than a human hair. It's basically this giant, high-tech parasol that blocks all the heat from the sun, the Earth, and the moon. And this allows the telescope to just passively cool down to a mind-numbing -266°C.
Now here's where it gets even more interesting. This incredible power isn't just for looking back at the dawn of time, it's also being used right now to look for signs of life somewhere else in the universe.
Webb is the absolute perfect tool for studying exoplanets. You know, worlds that are orbiting other stars. And while it can take some pictures, its real superpower is being able to analyze their atmospheres.
So, when an exoplanet passes in front of its star, a a tiny sliver of that starlight actually shines through its atmosphere. The Webb telescope can catch that light and feed it into an instrument called a spectrograph. Think of it like a superpowered prism that splits the light into a whole rainbow of colors.
Here's the cool part. Different atoms and molecules absorb very specific colors of light, and they leave these little black lines in that rainbow spectrum. By reading these barcodes, scientists can figure out the temperature, the mass, and the chemical makeup of an alien sky. And, most exciting of all, they can look for the chemical signature of water, a pretty key ingredient for life as we know it.
So, from seeing the very first galaxies flicker on, to literally reading the air of planets hundreds of light years away, the James Webb Space Telescope is just completely changing our understanding of the cosmos. It's a $10 billion bet on human curiosity, and you know what? It just might be the thing that finally gives us the answer to one of our oldest and biggest questions.